Okay, this is the first video for Unit 2, Targets 3 and 4. Target 3 says I can solve an algebraic problem given a midpoint or a segment bisector. So we're going to learn what both of those are with definitions and do some problems with them. A midpoint. A point is a midpoint of a segment if and only if it divides the segment into two congruent segments. So we chose to write this as an if and only if statement. A midpoint is a definition. This is the definition of midpoint. Definitions can always be written as an if and only if statement, which means it's a biconditional statement. A biconditional statement is a statement that can be written in if-then form, where the original statement and the converse are true. So if I were to take this and just put it into an if-then form, you could say if a point is a midpoint, then it divides a segment into two congruent segments. All right. So that's what I said. If a point is a midpoint, then it divides a segment into two congruent segments. And we want to note that the converse is also true. So the converse would be if a point divides a segment into two congruent segments, then the point is a midpoint. So it goes either way. Symbolically, we could say midpoint goes to two congruent segments. So maybe we wouldn't use just symbols, but we could abbreviate it. If midpoint, then two congruent segments. Okay. Since the converse is true, we could also say two congruent segments are divided up from one single segment. That means that they're divided up at the midpoint. So back on our diagram, we show a segment AB, and we show congruence, like if we know it's congruent, we show that with these tick marks. Okay, we call those congruent marks. And we'll use those all the time in geometry with segments and angles and different things. So if M is the midpoint, then we know that AM and MB are the same size. If AM and MB are the same size, we know M is the midpoint. Just as a reminder, the word or the symbol for congruent is made up of equal, which means that they are the same size. So if one is 5 units long, the other one is 5 units long. And then this symbol is a tilde. It's our symbol for similarity. So similarity means that they're the same shape, which is kind of weird because, yeah, a segment is always the same shape as another segment. But we'll talk more about what that means as far as triangles and other shapes go in geometry. Not all triangles are similar. They have to have the same ratios. So we have definition of a midpoint. It's a point on a segment that divides a segment up into two congruent segments. So given M is a midpoint of AB, what's the ratio of the length of AM to the length of AB? So for example, if AM is 5 and M is a midpoint, I know these are congruent, which means that they are the same size. So if AM is 5, then MB is 5, and the entire segment AM is 10. So the question is, what's the ratio of the length of AM to AB? Well, in this case, it simplifies to 1 to 2, which makes sense. AM should be half of the entire thing. MB should be half of the entire thing because it's a midpoint. Other things we can do with midpoints, if we know that M is a midpoint of the segment, then we know that it divides the segment into two congruent segments. So 4x minus 1 has to equal 12x minus 17. So if we know we have a midpoint, we know we have equal parts, equal sides of the midpoint. So congruent segments, equal measures. Subtracting 4x on both sides gives me 8x, and adding 17 on both sides gives me 16, dividing by 8, and x is equal to 2. Always in geometry, you need to make sure we answer the question. The question is find MQ. So if x is 2, then it gets plugged in right there. So 12 times 2 minus 17 is 24 minus 17, which is 4, 7. So we would say MQ equals 7. We can then also find PM. Doesn't ask for that, but PM is also 7. We could check that. 4 times 2 is 8 minus 1 is 7. And PQ, if I looked at the entire thing, remember that ratio 1 to 2, so PQ would equal 14. Same thing on this one. Given M is the midpoint, find the indicated length. M is the midpoint. The two segments on either side are congruent, so their measures are equal. So if I subtract x on both sides, I get 4x equals 12. Divide by 4, and I get x equals 3. This time says find the whole thing, MQ. Okay, so it doesn't matter, but you can plug it into either one. 5 times 3 is 15. So if this part is 15, then MQ equals 15, and PQ equals 30. Because PQ is the entire segment. So feel free to go back and watch the examples if you need to see them again. The last one we have to do with midpoint is kind of a tricky problem. It says the length of XY is 24 centimeters. So I'm not sure if I'm supposed to start with X and Y on the outsides, but we'll try that. And let's say that we were supposed to do that, so this whole length is 24. It then says the midpoint of XY is M. So we'll put an M there. And C is on XM, so that XC is 2/3 of XM. Now before we do anything else, we could just say if M is the midpoint, then XM is going to be 12, and MY is going to be 12. So 24 for the whole thing, 12 for each side. Now they're saying C is on XM, so on segment XM, so that XC is 2/3 of that. So that'll be C. And so we could take 12 divided by 3, because we're talking about thirds. So 12 divided by 3 is 4. So 1/3 is going to be from C to M, and 2/3, 4 plus 4 is 8, will be from X to C. Point D is on MY, such that MD is 3/4 of MY. So D is on MY, such that MD is 3/4. So there's D. So this time if I divide 12 by 4, I get 3. That's 1/4. And then the 3/4 will be 3 plus 3 plus 3, or 9. So 3/4 from M to D, 1/4 from D to Y. And the question is, what's the length of segment CD? So CD will go from here to here. So 9 plus 4 is 13. Sometimes in geometry, you just have to take it one line at a time and put down your numbers, mark your diagram, try to figure out what's going on. And so that's it for midpoints. Just to double check. Yep. So that's it for the midpoint video and definition of a midpoint.